Good morning, dear participants. This is the second session of the course. The course organized by Defense Technologies Society of METU NCC and supported by Science and Technology Society. Uh, you remember in the first session of the course, we completed the introductory part. Well, introduction, made a brief review at the beginning. What is stress? What is strain? And also, one more time, I highlighted, why we use von Mises stress or Tresca stress, Tresca yield criteria or von Mises yield criteria. If the material is a ductile material, well, commonly used one, it completely almost suits to the case, is von Mises yield criteria. So, well, when we run the software in Fusion, in Nasran, using the basic stress analysis tool of Inventor, the program drops the von Mises stress distribution. Okay. But of course, if you want selecting the option, you can see the first principal stress, second principal stress, shear stress, etc. At that part, first session of the course, I highlighted if you indicate a surface to say that there is a boundary condition such as force type boundary condition, then the indicated surface is completely selected and software will distribute the load over the surface entirely, uniformly distribute. Today, yes, in the content of the second session of this course, well, I am going to explain or demonstrate or answer the question depending on the point of view. The boundary condition is not valid on the entire of the surface, but it is, for a certain part of the surface. How can teach the software that the surface is not entirely to take, but a certain part of the surface is the surface. Over there we have a contact between the system and its surroundings. Okay, you know the free body diagram and how it is drafted, constructed. We separate the parts. For that part, there is something to deal, for instance, stress analysis, etc. Okay, after isolating the part, then it is more common to say system, and the rest of the universe is surroundings. And drawing the free body diagram, studying on the stress analysis, etc., we consider the forces, okay, the effects applied by the surroundings onto the system. Okay, at this stage in the virtual environment, if we indicate the surface to say that there is a boundary condition, force type, etc., then that surface is completely selected. Okay, but say in the case, today gonna study on such a case, the contact surface between system and surroundings is not entire of the surface, but a part of the surface. In this regard, well, after seeing how it is achieved, then can find the answer of the other question. The force is not a distributed force, but a point force. You know, point force is an idealization. We say that, the contact surface between the system and its surroundings is very, very small. In theory, infinitesimally small, so it is like a dot. That's why it is like a dot, contact area, it is like a dot, we say point force. Okay? It is the other definition, it is also common, concentrated force. Okay, how can define that the boundary condition is a point force, concentrated force? Answer this question also. And first part of the course, I deeply highlighted that the classical stress analysis tool of Inventor can be used if these two conditions are satisfied. Well, the material will be completely to its all the points in elastic region. Yes, if it is so, then can use that classical part. And other condition to satisfy to have it as valid is the static condition, okay? If the state of the body is static, then yes, can use that facility. If not, then already made an introduction to Nasran, use Nasran. In the content of the second session of this course, well, I'm going to give an example. In Nasran, how can we use Nasran if the material is not in elastic region, but first elastic, and then under the action of the loading, yield will occur, and then it is going to be in plastic region. We're going to study on such an example in the content of today. The other topic, it is quite important, especially your computer is not a workstation, or say that, exaggerate the case, supercomputer, but you are using or need to use an ordinary computer, PC or desktop computer. Well, in theory, to be able to increase the accuracy of the solution, method is finite element method. How many elements are to be specified, defined? How many portions are to be in making the discretization? If the solution is to be exact, then the answer of this question, infinite number of elements. So the size of element going to be infinitesimally small, and the method, analytical method. Okay, for one of them, infinitesimally small element, write the equilibrium equations using stress definition. And then, yes, if you can, take the integral. You're going to have differential equation and then integrate it. That is the exact solution. But for complex geometries, it is not an easy case. How about the boundary conditions? Okay, we have triple integral achieved to take the integral. Not so easy. So that's why we have numerical methods. Finite element, not infinitesimal, but finite size element. Okay, yes, if you insist on having the results more accurately, very accurately, then you may attempt to divide the body into lots of sub-portions. But if we increase the number of elements, then, well, the capacity of the power of the computer, an ordinary computer, won't be sufficient to study on such a problem. So, considering that it is the condition, it is the capacity of the computer, obey to the recommendation. If the geometry of the body monotonely the same from here to there, it is size not changing, its shape is not changing. Okay, if it is such a part, then use a greater size elements, coarse mesh. But if at a part of the body there is an abrupt geometrical changing, two surfaces, okay, they would form a sharp edge if there were no flattening over there. Okay, then it's very critical. I think from the outcome of mechanics of materials course, if there is a sharp, abrupt geometrical changing, so over there you have a sharp edge, sharp corner. Yes, over there will be stress concentration. The maximum stress is expected in the vicinity of such a threshold part. So since it is so, be able to find the solution, the stress value, more accurately, because that part is critical. Similarly, a certain part of the object there is a hole. It has been drilled. Okay, there is a cavity, empty space. Empty space within, say, continuous media will define discontinuities. Mathematically, we say discontinuous. If there is a discontinuity, again, yeah, well, it has also been experimentally verified. There will be stress concentration. Well, if you have such an empty space in the design of the object, in the vicinity of such a discontinuity part, use finer mesh, smaller size, finite elements. Okay, using this technique, yeah, well, it's a clever solution. Okay, although our computer is an ordinary computer, not workstation, not supercomputer, but still can use that computer to solve the problem. Okay, so in the content of the day, it exists. Well, such parts, how can have finer mesh? How can have smaller sized elements? The answer of the question to this, well, in such a case, in Inventor, yes, we have two alternative facilities. One of them is known, say, local mesh control facility. The other one, mesh refinement technique and the corresponding facility. Also in the content of today, I want to talk about both, okay? Local mesh control and mesh refinement techniques. Not using default mesh size, but under the control, change the mesh size. And of course, the course title says also the tools of fusion. Well, very crowded content for today. Also make an introduction to the fusion environment. Okay? Yes. Okay then. Well, to be able to save time, yes, since we have already defined the work in the first session as a project, you know the value of defining the work as a project quite well, because sufficient talk about it. Now, instead of passing through the definition stage one more time, for saving time, yeah, yes, say that. Activate the already created or defined project. See how it is activated. Yes, the work, you know, is, well, we studied using the tools of Inventor, so we have the project as associated. Okay, open Inventor, and then, yes, there is a project, it has already been defined, and need to continue on the rest, need to activate the same project. How it is done? The first thing to pay attention to satisfy is that, well, after opening the Inventor, see whether still there's an active file. If there's an active file in the environment, then you cannot activate the other one. Okay, first, if you have any, close all the files. And then the other thing to satisfy, you know, this is the arrow to click to drop the list of the names of the projects. Those have already been defined. In the memory of the computer, we have the log files, okay, definition files. So Inventor knows how many projects have been studied already. Well, in the list, from the list, select default option. If default option is the selected one, this means there is no active project. Okay. If exists, if you have an active project, okay, selecting default option inactivated. And then, well, take a right to define a new work as a project, or if it is the case, to activate an already defined or created project. Okay, our project is already defined, and you know, in partition D, we have the project folder. It uses your surname, ID number, and says Subtech course. Okay, it is the project folder. Now, in the memory of my computer, well, the address is almost the same, but, well, deeply nested. I have lots of subfolders. Okay, then, to be able to activate the project, follow this path. Well, I'm sorry. Well, recording the things, Dunya may help you, may assist you. Okay. Sorry. Well, time is very limited and cannot take my assistance. Okay, during the record. Sorry. But after the course time, then you're welcome, of course, for any question. You can find me. Okay, clicked on File tab. Okay, and via which drop this list. Move the cursor onto Manage option. Don't click. Shift the cursor to this pane and then find projects. You know, first session we followed this path, but we did it for defining the work as a new project. Here we need to activate the project. Okay, after selecting projects option from the pane, then yes, you're going to find this dialog box. Not a new project. If it were the case, we would click on new project button, but here our purpose to activate the project. Clicked on browse button. Okay. It is going to bring the search dialog box. In the dialog box, show the address of your project folder. I know where it is. Okay, it is in my computer, memory of my computer, partition D, and then the project folder, Saltec, etc. You know the name of the project folder. In my course, it is nested within this main folder. Savunma teknolojileri, yes, Defense Society course. And then, well, Saltec course, this is the folder of the project. Open the project folder, and yes, if the work has already been defined as a project, we find this log file, project definition file. Okay, Inventor creates such a file. Its extension is IPJ, Inventor project. Select it with a click and then say open. And then clicked on done button. That is it. Now we activated that project. And then, dear students, first I'm going to demonstrate how can say that the boundary condition is not over the entire of the surface, but it is applied to, it is valid at a certain part of the surface. I'm going to use the same model. So when clicked on open an existing file button, Inventor knows that it is the active project, and without asking the address, you see Inventor dropped the content of the folder in form of list. This is the solid model file, I know. The other folder, you see, you know, first session, I deeply underlined that it is so. Whenever we use stress analysis tool of software and thereafter save the file one more time, then software automatically creates such a special folder. It uses the same name of the solid model file. In this file, Inventor creates and keeps the log files, the results of the calculations. We run the software using the classical stress tool and also NASRun. So I am sure if I open this folder, can find AIP folder. Within this folder, Inventor keeps the results of the calculations. Okay. Those have been output using the classical stress tool. Yes, open, and then finite element analysis folder, and then can find the log files. The other one uses this name, INCAT, NASRun INCAT. Okay, it is the folder to find the log files. Okay. I cannot see the log files because the file format say IAM, IPT, IDW. If I say all files, then can find the log files also. Okay. Close this parenthesis, select the solid model file, and then say open. Yes, you know, we selected in first session a very simple problem for which we know the analytical solution. Well, for verification purpose, we did it. we know the solution, analytical solution, and then check using the tools of Inventor and also Nasran whether the stress values, strain values, displacement values, factor of safety values are the same. And the answer, yes, we said, yeah, yes, the same. Okay, so software solved the problem correctly. Solves the problems correctly. Okay, then, well, if you need to have a look at the results of the calculations, those have already been done, you know, similarly, make the same click on environment step, and then let us have a look at the values. Well, we output them using this facility, classical tool of Inventor. Open, clicked on this. Yes, Inventor, you see, well, at the browser enabled us to see the things in study browser, the other one model browser. Yes, this yellowish arrow is representative one. It is not to say point force. It's a distributed load. It is distribution is over this entire surface, entire of this surface. At the other end, we have a fixed connection. Okay. And then the results already output. Well, if you need to have a look at one more time, bring the cursor to browser, find results icon, clicked on the listing arrow, and then von Mises stress. Of course, if you have the special folder in which software keeps the data is associated and still over there, yeah, you can have a look at. No need to run the problem again. Bring the cursor onto von Mises option, for instance, right click the mouse, and then select activate option. Then yes, here is the stress distribution, von Mises stress, maximum stress 17 megapascal. Have a look at which mesh we used. Clicked on this button to have the mesh, the grid. Well, Inventor says that for this problem, 720 finite elements have been used. Well, those come from the default configuration of Inventor. You know, if we clicked on this button, we can see the default setting. Well, Inventor in it is default configuration. Well, use the average element size as the fraction of the overall size of the body. 10% of the say the overall size of the object is used as the average element size. Minimum element size is the 20% of the average element size. Saying default configuration, I mean this setting order. Okay, how about the other solution, Nasran? Clicked on finish button. Of course, one more thing. Okay, studying on the second example of today, I can highlight it. Okay, now Nasran, the results of the studying using the tools of Nasran. Environments, clicked on this button. And then, yes, similarly at the browser, we can find the icons. But if it is Nasran, then, well, the results icon will be in like a ghost, lighter tone, where the results are not ready to have a look at. Well, need to load the results. Either bring the cursor onto results icon, right click the mouse and select load, or equivalently click on load results button. Okay, which one you like. After saying load, if the folder, you know, in which software keeps the data still at the same address, then, well, Nasran can automatically gather it. But if you change the address of that folder because of any reason, then after clicking on, say, load button, then in the search dialog box, be able to indicate the folder, indicate the log files. Okay. And then the rest, after having the results one more time active to have a look at, right click the mouse and select display option. for having displacement value. Or one misses stress, bring the cursor onto the one misses option, right click the mouse and select display option. And then you can see the one misses stresses. If you want to see the values in megapascal, change the unit to megapascal, etc. Okay. And then clicked on exit button, and after making a brief review on the already subjected things and also highlighting how a project is reactivated, how the results can be dropped to the screen, then yes, answer the question here. How can teach the software that the boundary condition is not over the entire of the surface, but a certain specific part? Okay, for that purpose, I'm going to, use this surface and that surface. Over this surface, the boundary condition will be a force, but point force. Well, the mobile phones, dear participants, mobile phones. I don't want to say the rest. It is to be enough. Mobile phones. Teacher said mobile phones. Means forbidden to use. Don't use your mobile phones. Okay. Of course, for recording my delivery, yes, you can use your camera. But if you are using for chatting, for playing computer game, kindly request you. This is not a formal semester course. Voluntary basis, you participated. So, if you do not need to listen to me, then, well, feel free, you may go. Yes. Okay. Sorry. Okay, now, if you're going to define the boundary condition at a certain specified part, well, the technique is that in Inventor, split the surface into sub-portions. Okay, I'm going to split this top surface, okay, of the prism, and also split that tip surface. Okay. Well, for splitting surface, if the split tool is on the one plane, then recommend use this work plane facility, drop the list of the options and select offset from plane option. This option requires a flat reference. If in the design of the object there is no flat reference, then after starting the process, you can one more time indicate the coordinate plane as the reference. At the browser within origin folder, Inventor keeps the icons. Shall you use XY plane, ZY plane, which plane is the reference? Indicate that coordinate plane as the reference and then write the offset distance between the reference plane and the work plane to have. But here, since this object has a flat surface here and also there, you see it has 6 sides, all of them flat, so no need to indicate the coordinate plane. But if it were a revolved body, it has no flat surface to indicate, then we would indicate the coordinate plane as the reference. Okay, I dropped the list one more time, select offset from plane. Now, to be able to split the surface, I need to have, like a knife, a plane. It should be perpendicular to the surface. I indicate this surface as the reference. And then, the work plane is to be over here, like a knife, to split the surface for having indent such a portion. Well, from this window, I see the coordinate of the work plane, if it is to be at that side, relative to this reference, is negative. Okay, well, the size of the subsurface, or the coordinate of the boundary of the subsurface from this reference, in the example, say that 80 millimeters. It is to be written negative, minus 80. And then clicked on OK button. Yes, this is the tool. There is a work plane over here. It is to use for splitting the surface. Okay, for that purpose, the facility is over there in Modify panel. It says Split. Clicked on the button and in the dialog box, check whether Select Tool option has been toggled on. If the boundary of the tab, it's a very wide tab, you see, is blue, this means it has been toggled. So, software ready for your indication. Move the cursor to the vicinity of the work plane and indicate it as a facility, as a tool. And after making such a click, then you see Inventor toggled on the next one and enabled itself to distinguish which surface is to be split. If you clicked on the screen box, then Inventor can split the body. But here, for having sub-regions over the surface, to use different boundary conditions, well, surface is to be split, not the body. So that is okay. Which surface? Indicate the surface with a click. And then say OK. Yes, now we have over the surface, we have two regions, this and that. Okay. Similarly, one of the boundary condition in the example of today going to be point force, practically say point force, and it is to apply on the surface. Okay. Okay, then similarly split the surface, but you see, well, here over the surface, it is to have practically point force. Well, at this point, it is important. Well, you are using a tool as a part of surroundings, and the tool is a rectangular prismatic tool. Using this tool, if you're going to apply the force, then define the contact area as a rectangle. But if you're going to use a cylindrical piece, rod, okay, bar, cylindrical bar, it is contact surface going to be circular. Depending on the case, which tool going to be used for applying such a concentrated force, then accordingly define the subregion. In this example, say that it is circular. So select the surface with a click, right-click the mouse, and then say New Sketch. Okay. After starting the sketching stage, if the contact area is rectangle, create a rectangle and locate it relative to the boundary of the main surface. But if it is circle, click on this, and then create a circle first. Change the visualization style, can much more easily see the sketch. Visual style, not shaded with aids, not realistic, but wireframe. Yes, can much more easily see what it is. Could you please turn the lights off? Okay. The contact area, diameter, dimensional constraint. Okay. The diameter of the contact area, to say that relative to the size of the surface, it should be small enough. Say that its diameter is 6 millimeters. Or a little bit greater, 8 millimeters. Okay. And then the location dimensions. In the example, I'm going to locate the contact area. It is the area between the tool of the surroundings and our system to the centroid of this surface. So, I remember the location, the size, the width of the cross-section is 100, height of the cross-section is 50. So, if it is necessary to have the contact area at the center of the surface, then this coordinate is to be written as equal to 50. Okay? And relative to here, the other coordinate is 25. Yes. And then after having such a sketch, okay, then have the tool, work plane. Okay, not by using this facility. Use this facility for having flat planes, but here the plane is a circular plane. Okay, to be able to have a work plane, not to invoke. This is the work plane facility of the software, and selecting the option, we can invoke a work plane. It is going to be unlimited in size. But if none of them is suitable for your purpose, then can create a work plane. First have the sketch and then apply extrusion process. Click on this button. But there is a trick. If you simply apply extrusion process, then as it can be seen here, okay, change the visualization style to more realistic one. Inventor will be ready to create a solid feature. No, my purpose is not to create a feature, solid feature. My purpose is to have a surface, cylindrical surface. Clicked on this button. Now Inventor understood that it is a surface, not a solid body. Well, the tool, I'm going to use this cylinder as a tool for cutting, for splitting the surface. So well, have the work plane extended in both of the sides, toward the body and to the atmosphere. So symmetric distribution may be used. The length of this work plane is not so important. It may be a few millimeters, or if you want, say a few kilometers. Okay, it is like a knife going to use for splitting purpose. Okay, and then say okay. And then yes, the rest. Split surface. At present, the surface is entirely ready to select. But if I say 3D model and split, yes, the same dialog box. Which tool? Indicate this surface as a tool. Which surface? Indicate that surface. And then say OK. And you know the good practice, whenever you use work plane for doing something, then indent, take the visibility of work planes from the screen. If it is while the work plane, you had it using this facility, at the browser you find the icon corresponding. Bring the cursor to the browser, right click and deselect visibility option. But if you created work plane applying extrusion process, then you're going to have brown color icon. It says extrusion. Bring the cursor onto that icon, right click the mouse and deselect visibility option. And then, yes, one more time, see. Bring the cursor here, you see now we have a sub-region, there another region, and over the surface we have this part and also this tiny part. Well, at this stage, boundary condition defining stage, gonna use this surface as the contact surface. Since it is relatively small enough, can assume that force is a point force, concentrated force. Okay. Yes, the model is okay. Well, today we are going to solve the problem, one more time, but using different boundary conditions. To be able to have the files and also the valuable folder within the same project folder, and also via which to see the history of your studying, I recommend using the date of studying, save the file. Yes, we modified our body, split its surfaces. So, well, let us save the file with a different name. Okay, save as. Clicked on File, Save as option, select Save as option. And then, yeah, well, it was the 16th of March last week, but today is the 23rd of March. Okay, surname ID, it is our first part, part 1, that is reasonable. Date of today, March 23. Clicked on Save. Dear students, this is important. Dear participants, this is important. Well, before running the software to find the solution, yes, rename the file if necessary, save it, and then run the software. If you inverse the way order, then well, cannot find the log files within the created folder of the software. It is important. For instance, you run the software, found the stress distribution, and said that, yeah, change the name of the file. Yeah, you can change, but the log files will not be associated. So it is important. Have the solid model, save it, and then use the stress analysis tool. Okay. First point force, and then, well, one more time. Using the same model, gonna study on two different examples. Okay, clicked on environment step. Well, since Nasran is more complex because it is more powerful, can use this software not only for linear analysis but non-linear as well. Heat transfer phenomena, study on impact mechanics, buckling, okay, thermal stress, etc., some others. Well, the things correspondingly more complex to deal. There are tricky details. If you're sure that the body will be in elastic region and under static conditions, do not select Nasran. It is much easier to use. Select the classical tool. Okay, first select this tool, classical stress analysis tool of the software. Okay, for the same body, first session we have already used the facility. So, well, we have, you see, it says static analysis 1 at the browser. But next to the icons, we have now thunderstrike symbols. Okay, or if you want to say that, Thunderbird symbols. Well, Inventor bringing the symbol saying that, yeah, well, there is something which has been changed. Yes, we split the surface. So, well, the body is in the new form. So the already output values are not valid. These are up to date. These are to be up to date. How can update it? For instance, bring the cursor onto mesh icon, right click the mouse and say update mesh. But don't make such a thing here. I'm going to define the studying as a new analysis. But say be aware. If you're going to continue on the rest in the same analysis, then update the solution, resolve the problem. Okay, of course, although we split the surfaces, but we rerun the software, we are going to find the same results. Because surface splitting will not affect the calculation. But Inventor distinguished that there is something which has been changed. Or, well, maybe the case you increase the magnitude of the force or decrease. Or you define one more boundary condition. Again, the already output results will have with a thunderstrike symbol. An Inventor will friendly notify the user, say that these are not valid, already output value is not valid, it must be up to date. I want to keep the already created ones, output ones, in the memory associated with this body, but need to study on a different problem. Object is the same, but the problem is not the same. We have different boundary conditions. So, well, for saving time and effort, instead of starting from sketching stage and first create the model and then deal with the rest, no, well, use. One more time, click on create study button. Object is the same object. And the problem is static analysis type problem. Then say OK. You see now at the browser, the static analysis icon in compact form, okay, and it is not active. It is now inactive. The new one is active. Okay, this is the second studying for the same object. If you want to turn back to the previous analysis, right-click the mouse while the cursor is on that one, and then say activate. Then the first analysis will be active. Then thereafter you can have a look at the results, and the other will be inactive. But our purpose is to study on the problem in the second static analysis. So activate it one more time. Okay, and then the conditions. Well, my purpose is to answer how a point force is applied. Well, I have already tested. The first analysis, we said that magnitude of the uniaxial load is 80 kilonewton. But if you define such a load as a point force, in deformable bodies mechanics, the contact area is quite important. Well, for instance, I have a slide in my presentation. It is just to the point. Well, find that slide where it is. Yeah, it is over here. If the contact area is over the entire of the surface, so because you are using a special tool, applying the force uniformly distributed, then that is okay. There will be no stress concentration. But if it is a point force, then in the vicinity of the point of application, you're going to have greater deformation and also greater stress value. This point of application actually is a part, the stress going to be maximum. Okay. So if you define the load in the order, say that not, for instance, if you, I have already tested it. If I know that if I say that magnitude of the force is 80 kilonewtons, and the contact area is very little, like a dot, then I am sure from the output of my trial, the material will lose its strength. Even completely, fracture may occur. Okay? Plastic deformation, certainly, yes. Even, the stress may reach to a value in the vicinity of the point of application, it may be much greater than the limit, fracture limit. So if when you run the software, find the result is greater than the fracture tensile limit, okay, ultimate stress limit, then this means you cannot use this object in that size, with that material, and under the action of such a loading. Can do what? Well, knock the door of the customer and say that, is it possible to change the size and or the shape of the product? If the customer says yes, why not? Then okay, redesign it. Or similarly, can ask the permission for decreasing the load. Okay. Well, I'm going to use this scenario, say that not 80 kilonewtons after seeing the failure, say that a smaller load. For a smaller load, I'm going to, if it were a full semester course, then I would say that, okay, then try, see the failure, and then change the boundary condition. But here, that's why I say already tested that it is so, believe me. So, I'm going to apply the load, not 80 kilonewtons to this point, but smaller. Okay, well, the fixed connection is at this side, clicked on. Of course, one more time clicked on materials button and then check. At the model creation stage, material has already been assigned input. Along the row, I see the name of the material, code of the material, ASTM A36. If there is no name here, then this means the material has not been input yet. Clicked on materials tab and then from the library find the material option and then right click assign. Okay. And also in the dialog box, clicked on this listing arrow and then select which one is the case. Whether plastic deformations are allowed. If yes, in defining factor of safety, you can use ultimate tensile strength. But plastic deformation is never allowed for that usage, for that object, while it is being used. Then select yield limit as the threshold value for factor of safety threshold. Okay. And then yes, the next part is constraint panel. Clicked on which kind of constraint you have. In our example, it is a fixed connection. Okay, well, this surface has been welded, fixedly connected. And then say okay. And at the other end now, in this analysis, we have a point force. We have already split the surface. Okay, clicked on this option, and then in the dialog box, if the force is an oblique force, then make a click into this little box and then write the XYZ components. Okay. But if it is normal to the surface, then no need to deal with components, just indicate the surface. Now the magnitude of the load in this example, do you remember Dünya yesterday we selected the force in which order? Okay, let me say 3 kilonewtons, 80,000. Yeah, yes, but if you apply 80,000, then you're going to see the failure. I said, don't use 80,000. Yesterday in the other course, Dünya, my student in that course, well, we already studied on such things. Well, I'm going to say that, okay, boundary condition is 2 kilonewtons. Where is the surface? Say, indicate this little surface. Okay. Now, the representative arrow, over this surface, this circular surface, we have a distributed load. But since this area is smaller than the main area of the main surface, we can approximate this boundary condition as with your point force. It is a tension type load, so flip-flop the direction using this facility, and that is okay. And then, well, in this example, going to use the deform mesh setting. Clicked on mesh generation button, and then yes, well, we have 659 finite elements. Okay, and then ready. If you're going to consider the body force, gravity, clicked on this button and then teach. Where is the earth? This side or that side? Well, demonstrate. Clicked on this. Default configuration of Inventor considers the body at the sea level, so you know the gravitational acceleration is 9.81. If you indicate the surface, then yellowish arrow will be toward the Earth. Do you know Earth is at this side or at the opposite side? If it is below the body, then consider this representative arrow. It is toward the center of the Earth. Okay? Be aware. But since this bar is a little bar relative to the magnitude of the forces, I am going to neglect the weight of the object. So cancel this attempt. And then clicked on run button. Simulate means solve the problem. Clicked and then run. You know, previous studying, well, magnitude of the force was 80 kilonewtons, and we found the stress in the order of maximum stress 17 megapascal. But right now you see we have the force. It is not 80 kilonewtons, it is 2 kilonewtons. Although the magnitude of the force much smaller than that of the previous one, stress you see is much higher. Not 17, but it is doubled almost, 74 megapascal. And where is the point where the stress is maximum? It is in the vicinity of the point of application. Zoom in, and then yes, you see the color at this part where we have the load is near to red. Well, if the yellowish representative arrow is preventing you from seeing the place, then be aware in display panel there is a facility, toggle this button off. Then yes, you see that maximum stress is over there as it is expected, and see the deformation at this end. Yeah, yes, zoom in, yes, you see it is deformable bodies mechanics. Yeah, well, the maximum deformation is over there. But say since the stress is less than the yield limit, then yes, can conclude that this solution is valid and approximately true, of course. This is not integration technique. The solution is approximately true, sufficiently true. Okay, that is okay. Well, there may be some other details, but you know, this is a short course. If you want to see the mesh, then toggle on this button. And then animation, and if you want to see the actual deformation, drop this list and select actual. Then actual deformation is in the order of less than 1 millimeter probably. If you want how much, then you can select displacement option and activate it. Factor of safety, etc. Already talk about the things in first session of this course. Well, there is no other complementary things. The valuable thing to highlight in this work is that how a point force is defined. I think I achieved to answer this question. Finish this analysis. Okay. And then in other analysis, the body is the same body. Okay. But the conditions are different. So clicked on environment step one more time. And then yes, stress analysis. Now we have at present two analyses. First analysis, second analysis, and then the next one, third analysis. Clicked on create study button one more time. It is going to be a static analysis again, not to find the resonance frequencies. Okay. Unfortunately, the time of the session is not sufficient to study on model analysis. Okay. If you're interested with the model analysis part and also interested with the other tool of the software, well, today we have a facility in the structure of Inventor and also in Fusion. Using that tool can save material, via which can have the object part quick response object. Okay, Inventor recommends decrease the mass here, here, and there. Why not? Instead of designing such parts as full of materials, well, can have empty spaces. Yeah, software, recommends such a valuable thing. If, yes, we design the object accordingly with some empty spaces, this means our product going to be more sustainable. Okay, because material is a very valuable natural source and save material. Don't use material unnecessarily. If the factor of safety is in the order of much greater than 1, 2, 3, 4, okay, for instance 15, 20, etc., then it indicates that over there you can decrease the material. Either decrease the size or completely have empty space. So, well, here, if it is the case to deal, then select shape generator option, you know. But in this short course, there will be no example, no demo, how it is achieved, how it is done. Okay. So, well, this analysis, again, it is the case. Our object is under static conditions and hoping that the material going to be in elastic region. First try. Okay. And now the previous ones are inactive and the third one, software is ready. I am sure material is recognized, okay, previously tested, and this analysis, I am sure the inventor knows the material. No need to click on this button because I am sure. Okay, boundary conditions at this end, which end? This end, the connection is fixed. And the other boundary condition, of course, later, it may be in other studying at your site, you may define more boundary conditions. At this end, point force. At this side, distributed force. Over this surface, at that part of the surface, along this part, distributed force. over here another distributed load, combined loading. And also clicking on this, you can define torques, bending moments, okay? Clicking on this, you can define body force, etc. At home, you may be interested. But here in this example, again, it is going to be not a combined loading, okay? One boundary condition. Clicked on force button. Boundary condition is a force type boundary condition. It is acting over the surface, already split. Yeah, the magnitude of the force, 8,500. Or say 9,000, yeah, 9,000. 9,000. Well, indicate the surface. It is perpendicularly oriented with respect to surface. If it were oblique, then I would click on this and then write the XYZ components. You know this. The sense of the load is correct. It is a pushing force. And then say OK. Well, actually, software knows this. Okay. Well, of course, we have shear stress and also bending moment. Obvious. Well, do it. Well, made a wrong click, probably. Okay. Ah, yes, that's why. Okay. Okay, right. Okay, I'm not so sure. Forgot to click on OK button. So, well, yes, first clicked on this display button. Yeah, yes, okay. I have clicked on OK button. And yes, this is the boundary condition. And now with this such a lateral directed load, you know, famous name, it is a cantilever beam. At this end, it has been fixed connected. It is like a beam. Whenever a bar or prism is loaded laterally, then we say, okay, it is a beam. In the jargon of civil engineers, it is called beam. Okay, this is a beam. If its end is fixedly connected, then it is said cantilever beam. Maximum deflection will be at the free end of at the side where we have the free end. Minimum deflection here, but the maximum stress is going to be in the vicinity of this fixed connection. Okay, now I do not remember the yield limit for the material. Have a look at. Clicked on this button, and then. By the way, yesterday you asked me. Well, be aware. Although at the beginning we selected a metric unit system, and thereafter Inventor start to consider the given values in millimeter. But unfortunately, the physical, mechanical, thermal properties are represented by the software in default unit system. It is what? It is customary American or British unit system. Well, it is a tricky. Well, to be able to allow yourself to see the results of the calculation in SI unit system, the thing to do is that bring the cursor to here, to the lower left-hand side corner. There's an arrow here. Click, drop the list, and select Set Display Unit Options. And then in the dialog box, well, the automatically selected option going to be on English option. If you need or want to see the values in, for instance, KSI, not megapascal, but kilopound per square inch, KSI means kilopound per square inch, thermal values in British thermal unit, etc., then select English. But here, well, the one selected by me is metric standards. Okay. And then, if the material has already been input, can find its name in the upper pane. Bring the cursor to here. Over there we have a button with wooden pencil. Click. Okay. It is to bring this dialog box. Select physical option. And then yes, the properties, thermal properties in SI unit system, which ones, thermal conductivity, etc. mechanical properties and strength properties. For this material, yield strength is 248 megapascal, and the tensile limit after strain hardening, yielding, the hardness increases and the material can reach maximum to this limit. It is 400 megapascal. If this limit is exceeded, then the result, obvious fracture. Okay. In our studying, the threshold value is the yield strength. Okay, it is 248. Close this dialog box. And then, okay, run the problem. Okay, mesh, again, I'm going to use default mesh. Okay, run the software. Clicked, and then say run. And then maximum stress, as it is expected in the vicinity of the fixed connection, but unfortunately it says 300 megapascal. The limit for the material yield limit is 245 megapascal. This number highlights that, plastic deformation. This part will be deformed plastically, although we have stress value, but these are not true, because we use the classical tool of the software. While using the classical tool and seeing such a value, it is greater than the yield limit, say that, okay, probably there will be plastic deformations, but cannot use this part of the software. Okay, cancel this result, cancel this analysis, because the results are not true, not valid. Okay, and then say that finished analysis. Okay, clicked on environment tab, and then select the correct option for studying on the same problem, Nasran, of course. Okay, Nasran. Yes, Nasran. We have already used Nasran in the first session. So Nasran, since the project is the active one, the same project is active, Nasran remembers that while we solve the problem under the action of a certain load system, ready to represent the results. If we say load, then can see the results. But here it is going to be a new analysis. Okay, clicked on new button. Okay, and then there is a trick here in the dialog box. After seeing that, then the yield limit will be exceeded, then Nasran automatically selects linear static option, but we know that not linear but non-linear. So drop this list, and then from the list select non-linear static option, if of course the condition is static condition, under static conditions body. If it is thermal stress analysis, then select thermal stress option. Okay, if it is impact mechanics, select impact mechanics option. Okay, impact analysis option. But here in this short course, the case is nonlinear static. Nonlinear means plastic region. Okay. The other thing, yes, in the dialog box, it is recommended. Clicked on select unit button, and then select SI unit option, or if you select CAT model option, it is the automatic select option, then Nasran will represent the values, distance values, area, etc. using millimeter. In engineering drawing, we use millimeters in metric way. To be able to see the results in SI unit system, select SI, and then say OK. And then you see the first analysis is in ghost form, inactive. New analysis is active. And then the next stage. Clicked on idealization button. First, I recommend, although in the order we have materials tab to click, but it is just directly for being sure whether material already input and it is recognized, it has been recognized by this module of the software. Yeah, well, here the answer, if within this little display see the code of the material, then this means it is okay. Material has already been input and inventor knows the material. Okay. The other thing in this dialog box, it is a must to deal. Well, teach to Nasran. Body is not a shell, but if it is shell, thin walled body, then select shell elements. But in our case, it is not a shell, it is a solid prism, so select solid element option. And then say OK. Yes. Materials, yeah, it is important, clicked on this button. It is not to see the characteristic values of the material only. If it were thermal stress analysis, thermal analysis, then I would say that don't forget to make a click into this little box to enable Nasran to use the thermal properties. Those going to be associated. But here for this analysis, not necessary because we are assuming that temperature is uniform. Okay, complete this exercise and then classwork and then we're gonna have a break. Okay, kindly request you. Sure, for any inconvenience. And then, yes, this is extremely important. Well, we know that material will be in plastic region. So select nonlinear tab. After clicking on this button, then this sub-dialog appears. You know, from the theory and also experiments, well, for ductile material, stress strain curve is something like this. If we select plastic radio button, then within this little graph can see, yeah, elastic part, nonlinear part, plastic region. But if you select this option, then, well, the runtime may be in the order of even weeks, or completely software may vanish, and in the end, in the screen, after waiting too much time, bad news, failed. So, it is not an easy cake to perform the nonlinear analysis to its actual behavior. So, in this regard, it has already been tested analytically, experimentally, practically, numerical techniques. Almost all the researchers, academicians, and correspondingly the software of today make this assumption. Elastoplastic material. Not fully plastic, but elastoplastic. It's an approximation, but a valid, reasonable approximation. Select this option, okay? Well, the plastic region is approximated such that over there, the relationship between strain and strain again, say, direct proportional, okay? With this assumption, can use the software. At a shorter time, reasonable time, can solve the problem. Okay, this is also important. Select, don't forget to select elastoplastic bilinear option. Can close this dialog box. If you forgot to define the work at the beginning when you clicked on new work, okay, button, that the problem is a nonlinear type problem, then when you clicked on this button, Inventor will notify you, say that, okay, you did it, but it is going to be, this setting going to be valid if you change the analysis from linear static to nonlinear static. Okay, if you forgot to define the studying as nonlinear static, then Inventor will notify you, bringing such a notice to the screen. Close this dialog box. And then another important thing to deal before clicking on Run button, well, at the browser, going to find nonlinear setup option. Select it with a left click, right click the mouse and select edit option. And in the dialog box, well, since Inventor uses iteration technique, for in nonlinear analysis? Well, in this dialog box, need to write the number of increments. Well, the recommended increment number is 5, but if you're ready to wait too much, okay, then you can write even 20, 30, okay? But if you write a number greater than 5, Nasran friendly notify you. Be aware, the runtime may be too much. Okay, well, so since the course is short, I don't want to hold you too much, and also my time schedule is very crowded, even for weekend holiday. So I'm going to obey to the recommendation, and in the iteration there will be 5 successive stages. Inventor, thanks to this allowance, will start from 0 load, increase the magnitude of the load step by step, okay? And the results will converge, okay? If not converging, then increase the number of increments. Well, say that it is 5 in this analysis. This stage is not optional. There must be an increment value in this dialog written over there. Okay, and then, well, for this problem, again, gonna use default mesh, okay? Clicked on this one, mesh setting. This is default size. And then clicked on generate mesh. Okay. The boundary condition. Yeah, yes. Fixed connection. The order is not so important. Define the boundary condition and then generate mesh, or vice versa. Okay, fixed connection, one end, it is, cantilever beam. Well, if actually I forgot, okay, if I clicked on import from stress analysis, then, well, it has already been performed using the classical tool of Inventor. Then not the results, but the boundary conditions would be transferred to Nasran environment. But since I forgot to click on this button, okay, not so difficult. I'm going to define the conditions. There are 2 conditions, not time consuming thing. I said that this is the fixedly connected end. Well, there is no freedom to display, to rotate. All of them have been selected, you see. Well, the symbol going to be cyan colored. If you want to see it in a different color, click on this and change the color. Yes, this symbol is to say that there is no freedom at this end. Okay, this part of the body we have laterally directed load. We said that magnitude is 9,000 newtons. Okay, it's a force type load. Clicked on this, and in the dialog box, well, drop the list, whether it is moment, whether it is hydrostatic pressure, or thermal boundary condition, temperature, radiation, convection coefficient. Here in our case, it is a force. Select force. Well, from here, if it is not an oblique or inclined force, well, do not select components option. Select normal to force, normal to surface. Which surface? This surface. What is the magnitude? 9,000. Since in Nasran there is no flip-flop button to click to change the sense of the load, well, see, if the coordinate axis, positive sense of the coordinate axis in the up direction, yes, y-axis is in the up direction from this ellipse here. I see it is positive sense in the up direction, but in our example the force is in the opposite direction, so write the numerical value with negative sign. Okay, and then, to be able to draw the attention of the other persons that it is not a concentrated force, but it is a distributed load. In Nasran, for having more arrows, hold this sweep and move it to the right side, but not too much, only for having few arrows, and then say OK. Yes, now we have enough number of arrows to draw the attention of the other person that it's a distributed load. Okay, then I think we are ready to run the software. Okay, clicked on run button. Yes, see the increments, iteration. You see 5 increments. Step by step, Inventor at the background increasing the load from 0 to its maximum value. And then about to see the results, say, okay, good news. And then, yes, well, here in the list we have von Mises stress distribution, not Pascal, but I want to see the values in megapascal for this strong material. Yes, 297 megapascal is the maximum stress. Yeah, it is a value in plastic region. Yes, if customer allows that we can have plastic deformations in using the component, then that is okay. And here is the maximum stress. The other things, if you want to see the other ones, deformation order, factor of safety, etc., then you can have a look at the other results. Okay. From here, drop the list and select strain option, select reaction moment option, select other option, and then factor of safety, etc. Well, you may continue on the rest, but I think it is okay. Nonlinear stress analysis can be performed in Nasran, and the ones I highlighted them previously are the tricks to know to deal. Okay, well, I am stopping at this point for a break time during the break. Okay, well, finish this analysis. Yeah, yes, and then save the file with the date of today. Don't forget, otherwise the log files cannot be saved. Now I am sure Inventor at the background created a new folder. Well, have a look at whether it is true. This is the project folder here, and now you see the folder, log files folder for the previous session uses 16, March 16. Today we renamed the solid model saying March 23, and this folder just newly created by the software, it uses the same name. Open the folder and then have a look at the log files. We use under this, with this name, classical tool of Inventor, select AIP folder and finite element analysis, and you see we have lots of log files because we use that facility twice. Well, some of them just keeping the values of the point force loading analysis, and the other set is just for the bending type loading. But of course, well, the results are not valid because material reached to plastic region. And the other folder, INCAT folder, we use Nasran, okay, for finding the stress values, selecting nonlinear option, and these are the valuable files. Okay, these files are to be kept, otherwise the results of calculation cannot be seen. Okay, I am ending the record as well for this session. Okay, have a break and then continue.